Hi everyone, welcome to this session. Looks like it's pretty well attended. We've got almost 30 people. So it's a couple of minutes past the hour, so I might make a start. So got 3 sessions today. First up, we've got Valerie Dongmajongo from Stats Canada. So just before he kicks off, I'll just go through a couple of housekeeping points. Just so people know, for any questions for this session, for the panelists, feel free to write any questions in the Q&A chat box. Just note that the regular chat is disabled, so please put them in the Q&A. Do that at any time during the talk or after, and what will happen is that I'll go and essentially pick some questions and invite the questioners to be unmuted to ask. So that's just a heads up to put them in the Q&A box. And there'll be 10 minutes after each session to go through those. And yeah, that's pretty much it. Just without any further ado, given that we're running on a bit of a schedule, I'll hand it over to Valerie. Thank you.
Thank you, Andy. Do you see my screen? Do you see my screen?
I can, yes.
Okay. Today, I will present Statistics Canada's experience in the use of web scrape data in the Canadian Clothing and Footwear Consumer Price Index. The presentation contains 6 sessions. I will start with the background and the motivation of using web scrape data. Then I will move to the approach used by Statistics Canada for the collection of web scrape data. Next, I will present the development of the classifier as well as its implementation in production. Next, I will present the index number formula that is used in production. Then I will present how field collected data and web scrape data are combined together to produce the Clothing and Footwear Consumer Price Index. Finally, I will present the current research and development work to improve the Clothing and Footwear CPI. The 2 graphs here show that over the past... Yeah.
Sorry to interrupt you. I'm not sure that you're sharing your screen because I'm only seeing your camera come through. So if you go down to the bottom, there should be a share screen option.
Yeah.
Yes, I'm not sure that that's been activated yet. Something's coming through now. Okay, that's a bit.
Thank you.
Yeah. Yeah, great. Thank you.
Okay, excuse me for that. So the 2 graphs here show that over the past decade, the retail landscape has changed drastically as e-commerce expands, shifting bricks and mortar retail sales to online sales. The graph at left shows that Statistics Canada's e-commerce estimate has grown steadily from 2.2% in 2016 to 6.2% in 2020. Note that the share nearly doubled between 2019 and 2020 due to COVID-19 that leads to store closure restriction while online shopping remain available. The graph at right shows that the clothing and footwear industry followed the same trend, with its annual share of e-commerce rising from 8.5% in 2016 to 10.6% in 2019. The share was 23.6% over the period of January 2020 to May 2020. These 2 graphs together show that traditional field collection, which relies on a representative sample of product available in store may not provide sufficient coverage of the growing share of online product offer. The diagram here shows the sampling process to obtain the clothing sample for the CPI. It starts with the retailer survey frame, which consists of all establishments on Statistics Canada's business register classified to the North American Industry Classification System under the clothing and clothing accessory store of the retail trade sector. Although the business register clearly identifies the target establishment for the CPI, the clothing and footwear sample is not directly selected from the business register because it's like a sampling K variable, which is the commodity sales. Therefore, the clothing and footwear commodity sample is selected from the Statistics Canada Retail Trade Survey. The sample includes two categories. First category is retailer with exclusively physical brick and mortar store, and second category is retailer with both physical store and online presence. The web scrape collection mode is then an opportunity to improve the coverage by collecting a large volume of price and product offers that are available online at greater frequency. To improve the coverage of the online product offer, Statistics Canada follows a strategy that consists of progressively replacing field collected data with web scrape data for the retailer included in the CPI sample having both physical store and online presence. January 2020 marked the first introduction of web scrape data in production. 3 selected retailers were included in the web scrape methodology, collection and processing method. The 3 retailers represent together 8% of the apparel market in 2019. As a result of this change, Statistics Canada interviewers are collecting approximately 10% fewer price codes in the clothing and footwear stores every month. The graph here confirms that web scrape data improve the coverage. This graph is built using web scrape data from the 3 retailers for the month of January 2020. It shows that more than 50% of product offers were available online only. This motivates to move from the unique mode traditional field collection to a mixed mode collection that includes web scrape data to improve the coverage and quality. In the next section, I will present the web scrape approach used by Statistics Canada. A third-party company scrapes online data from each retailer website on a weekly basis since 2019 and 18. The data available on the retailer website are unstructured, and each retailer has its own unique website structure. Therefore, one of the contractual requirements with the third party is to provide a partially structured file for each retailer containing all information necessary for the use of in the CPI. Example of variable are the product name, the category, which is the retailer classification of the product, the description, which is a text field used to describe and promote the product, the feature, which is also a text field which lists the product attributes such as material, technologies, and construction, and the stock keeping unit, which is the identifier used by the retailer to track the product. The data provider generally scrapes data once a week. More specifically, the scrape is done during the week starting on Monday, and the data is delivered to Statistics Canada following Monday in batch using a secure transfer system. After that, an internal team ensures that the file arrives on time and meet the requirement of the contract with the third party. 4 main rules are used to for the quality control of the file received. Well, the role is the size of the file. Here we compare the size of the file received with the size of the previous month's file received. If the difference is large, that triggers more verification. Second rule is the integrity of the variable. For example, we ensure that value of one field, say variable A, is not copied into a second field, say variable B. Another rule is the number of records in the file. Similarly to the size of the file, we compare the number of records into the file received with the number of records in the previous file received. Large difference trigger more verification. And lastly, the validity of each record. Here we just ensure that each record corresponds to a product offer. When an issue is detected, the third-party provider is notified to fix it. When there is no issue, the raw data goes to the next step of the process, which is the classification. For the classification, we use the CPI classification, where the clothing and footwear subcomponent represent 5.7% of the CPI 2017 CPI basket. That subcomponent of the CPI is hierarchically divided into 4 subsequent subcomponents. Here, the clothing, approximately 64%, footwear, clothing accessories, and then the clothing material, notion, and services. Each of the 4 components is subsequently hierarchically divided into mutually exclusive subcomponents until the lowest level of the CPI classification is reached. There are approximately 78 lowest level classifications for the clothing and footwear. The classification process consists of mapping each product item to one of the lowest level of the CPI classification. Statistic Canada developed and deploy a support vector machine classifier using web scrape data collected since June 2018. The development of the SVM classifier was done in 3 phases. First, the labeling, where we use 12 months web scrape data from the 3 retailers to account for seasonality. Here, a random sample of approximately 14,000 unique products was selected for manual labeling. This consists of manually assigning to each sample record an appropriate elementary aggregate of the lowest level of the CPI classification. Thereafter, the label sample was split into the training set and the test set. The next step was the modeling. That consists of building a classifier that learns from the training set and assign a given web scrape product item to the lowest level of the classification. Several models were tested, including the support vector machine. The performance of each model was tested using the F1 score, which is an average harmonic mean of the precision and recall. Here, the precision is the percentage of relevant classification among the set of products that are assigned to the elementary aggregate by the classifier. And the recall is the percentage of relevant classification among the set of products that effectively should belong to the elementary aggregate according to the human. The elementary aggregate here is defined as the lowest level of the intersection of the product and geographical classification of the CPI with expenditure, where the expenditure weight are available. The results show that the support vector machine performed the best with the F1 score equal to 92.2% versus 87.8% for random forest. That was the second best among all the models tested. Hence, support vector machine was implemented in production. The production process has 2 key stages. First, the monthly run of the classifier, and second, the quality assurance for the predicted unlabeled product. The figure, this diagram shows that the classifier predict the elementary aggregate class using the raw unclassified data. The classified data are then aggregated for quality assurance manual review. The summary from January 2020 to February 2021 shows that the average number of manually verified unique products per month is almost 4,000. The average precision or average percentage of well-classified product is 95%, which is considered as a satisfactory performance. After quality assurance, manual work feedback are provided to the data science team. If there is a need to retrain the classifier, then there will be another run of the classifier. If not, data are aggregated to feed the CPI. The aggregation used the geometric mean as at the retailer level. All the product offer available are used. This index number formula is consistent with the Given formula used to aggregate all field collection price code at lowest level of the CPI classification. At this stage, the data are ready for the integration into the CPI. The lowest level of the CPI classification contain field collected indices and web scrape indices at this stage. For web scrape indices, we assume the retailer has a national pricing strategy. Therefore, calculated prices are used in all geography where retailer operate through either brick and mortar store or a warehouse for a local product shipping. Field collected and web scrape indices are aggregated using geometric mean to obtain the indices at lowest level of the CPI classification. The upper level aggregation is conducted using a fixed basket law formula starting elementary aggregate index. Before the implementation of web scrape data methodology, a parallel run for the three retailers was done to assess its effect on the CPI. For the parallel run, two CPI series were calculated. First, a series using only field collected data for all retailers. Second, a series using web scrape data for the three retailers and field collected data for the other retailer. This is the series in blue. The figure at left shows that at all item CPI level, the two indices are almost identical. The figure at right shows that at clothing and food, at clothing and footwear price index level, the trend are the same. Similar research and parallel run will be conducted as more retailers are included in production. Here is the list of future work to improve the web scrape CPI. First, the development of a user interface application of web scrape data process that will efficiently support the web scrape process and minimize the risk of error. The second concerns the classification, specifically the introduction of active learning, where the system decides which product should be labeled. This will be cost efficient in terms of sample selection for the labeling of future retailers to improve the web scrape methodology. The third concerns the clustering. Here, the objective is to mitigate the impact of production. The next research is the outlier detection that will efficiently target the candidate for quality assurance manual work. And the last research project in the list is the treatment of outliers. The intention here is to develop an outlier robust geometric mean estimator to reduce the variability due to the fact that elementary aggregate or the cluster do not necessarily include pure homogeneous product. To conclude, in this talk, I have shown that Statistics Canada is leading the way of unique mode field collected data toward alternative data source to improve the coverage and quality of the CPI. Research and development are conducted to smoothly include additional retailer into the web script collection and processing method. Thank you.
Thank you, Valerie. That was very interesting. We so far have one question that's come through from Tony Cox. Nathan, perhaps you can unmute Tony to let him ask the question.
It seems like Tony might be having problems unmuting.
Okay.
So you might want to read the question out to Tony.
Yeah. Yep. I can just I can read the question then. So the question, Tony's question is, can you explain the rationale for using the GM at the lowest level of aggregation rather than, say, Duto?
Thank you for that question. The geometric mean, I assume when he said geometry, he's talking about the geometric mean. So if he's talking about the geometric mean, as mentioned during the presentation, we are aggregating field collect data using the geometric mean. So at lowest level aggregation, we have the indices for each representative product. And the lowest level aggregation will contain many indices. For example, there may be 2 or 3 retailers. That means we will have 2 or 3 indices for field collected data. And we aggregate that using a geometric mean. So to be consistent with our approach of aggregating the field collect data at the lowest level aggregation, we also use the geometric mean before the stage where we reach to the indices at lowest level aggregation. Basically, this is the stage here where we have the lowest level aggregation, and we use the geometry as shown in the slide, and we use the geometric mean of all the web script products. This is to be consistent with the subsequent stage where we will have to aggregate field collected data and web script data.
Thank you. So we've got one more question from Matt L. So hopefully they'll have better luck unmuting. So just Nathan, if you wouldn't mind throwing it over to Matt.
Hello.
We can hear you, Matt. Go on.
Okay, thank you. Yeah, so I just wanted to ask, when implementing web scrape data, have you been able to approximate expenditure information at all to implement expenditure weights? And if you haven't, has any research sort of been conducted into this? And what kinds of methods have you explored with regards to that?
The difference between web script data and scanner data is that, unfortunately for web script data, we don't have the expenditure. So we don't have the quantity. I mean, for web script data, we don't have the quantity. However, we are using some weight, indirect weight, which is the number of product offer available when doing the scraping. And all this is aggregated using a geometric mean. But at the stage, at the lowest level of the CPI aggregation, as when come time to combine field collected data and CPI data, then we use the weight. We use the weight that are available, and those weights are coming from mainly from the surveyors household spending. Now there is a change where we are moving to the use of the system of national account weight. For the next basket that is coming, we will be using the system of national account weight. So the weight are used when field collected data and web script data are combined together at the lowest level of the aggregation. And these weights are coming from the system of national account weight, for example, and used to aggregate at upper level of the classification.
If I can also add in, just because both at Statistics Canada, there is also some people doing research in the consumer prices division for using online sales rankings to try and figure out weights for online products based off of their sales rank information. If that also answers Matt's question.
Thank you.
Excellent. So I'm not seeing any other questions come through. So that might be a good segue to Lance's presentation. We're right on 10:30 more or less anyway. So we'll hand over to Lance, who will be talking about estimating computers and peripherals price indices using web scrape data. So over to you, Lance.
All right. Sorry, you guys able to see my screen right now?
Yes, that's coming through.
All right, awesome. So hi, I'm Lance, Statistics Canada, here to just talk about our experience in creating the new computer equipment software supplies index, which is used by pricing computers and peripherals. Should also mention, it's not just me who worked on it. There's also Rubina Keshish-Banusi, but she's not doing the presentation. And yeah, so just going to talk a little bit about just background of what the computers and peripherals in question are, a little bit on the data. So good thing that Valerie went in more detail on web scrape data earlier on, and then just talk a bit about the quality adjustment that's performed and why we need to do quality adjustment for these products, and have it aggregated up into price indices, and then just summary remarks. So computers and peripherals are used to price the computer equipment software supplies index. It's not a huge basket weight. It's less than 0.5% in the Canadian CPI basket. And a few months ago, in the January 2021 consumer price index reference period, a new methodology and corresponding data source was integrated into the CPI to replace the old data source and methodology. So computers and peripherals is 4 products within it. The biggest product is laptops, then desktops, then monitors and printers. And the reason why there was a new data source is because the previous one was a little on the expensive side, and it had some issues where it caused a bit of lag in the series. And this also gave us an opportunity with a new data source with more information about the products we're pricing. We could do a bit more quality adjustment for them. So as I think Valerie went on this in his presentation, but we do have a third party who does weekly delivery of web scrape data to us. And because it's a weekly delivery, there's a couple extra advantages over the old data source that we had, where now we have eliminated one of the 2 months of lag that was caused simply by the collection of the data, but also now that it's weekly collection, we are more likely to observe the price change in the period that it occurs, which is relevant because in an age of online sales, there's more frequent price changes, or at least that's what the Billion Prices project has found. For a given item, because we observe it multiple times per period across multiple outlets, we just take the average price over the period that we observe it. The other data sources that are used for weights just come from a combination of industry reports and Statistics Canada's Merchant Retail Trade Survey. For the data in question, another month of what was formerly lag has been removed because we've automated most of the process. So now current production takes 1 employee 1 full day, which means it's a more timely index than before. The data itself, though, doesn't really come in a friendly format. All the relevant information that describes a laptop, desktop, etc., is online because a retailer wants to advertise to the consumer exactly what they're, well, more or less what they're getting. So there's a bit of work that has to be done in order to identify the characteristics we want to use in quality adjustment and make sure that the factor levels are all standardized and the continuous variables are all like turned into numeric variables with the same units of measure. Unlike clothing right now, there's currently no actual classifier used for the computer products. So we have like very rough rules-based filters. And then if it gets cleaned to a point where it has all the characteristics of the product in question, then it is deemed to be the product in question. But there is, of course, room for subject matter intervention at various stages in this process. So this is kind of example of just what it means when we have all the information there, but it's not necessarily in a friendly format. So for an example, for laptops and desktops, we would care about the size of the RAM and the type of the RAM, but it's not necessarily stored in consistent descriptions on the website across different products. So basically the information portrayed varies across different retailers and products within the same retailer even. So what we would want to get here is we'd want to figure out for both of these desktops, we would want to figure out how much RAM there was and what type of RAM it was. So when we have the data, we need to do quality adjustment for the products, because if we didn't and just use the continuities between periods, so the observations which were observed in the current and previous period, we'd be missing a lot of price changes that would be caused by new products being introduced with an implicit price change. So specifically for laptops and desktops, because they have a higher rate of product introduction than monitors and printers, and also we observed a greater pace of technological change, it was pretty important to make sure that we could compute a relevant back price for entering observations. And so we use a hedonic imputation approach to account for the missing prices of entries and exits. So this is just kind of an example of what I meant by there's pretty fast technological change. So you can see within the span of just 2 years, for instance, most laptops went from having, from having a majority of laptops having solid state drives to it becoming nearly the default in the past 2 years. You can see that in the past 2 years, the storage that a laptop tends to come with has actually declined pretty significantly. And this probably has to do with online storage becoming a thing. And a somewhat relevant point for the solid state drive and total storage capacity of a laptop is that at the start of the research, so when like in the initial periods in 2019, drive space and having a solid state drive were a lot more relevant in predicting price, but as they kind of became less relevant, it was showing up that they were less relevant predictors. But yeah, you can see in other things like touchscreens are more prevalent and the size of a laptop has been declining as they become more portable or consumer friendly to hold on and carry. Final note, processor total isn't an actual thing we use to control. That's just the product of the number of cores and the processor speed, which are things we use to control. It's just that it gives you a good idea, a rough idea of how CPUs have become more powerful over a 2-year span. Sorry. The other thing that I mentioned for the quality adjustment is the churn. And so this is just showing how for laptops, for just new entries, brand new entries each period, about 8% of the laptops used each period are brand new, unseen before, 7.5% of desktops, and then smaller, less for monitors and printers, where printers tend to be on the market for much, much longer, which is why we can justify using a matched model, say, for them. So for laptops and desktops, because we use a hedonic computation approach, basically all that we're doing is if a laptop is entering or exiting a given period, the period that we need adjacent to it to make a price relative has its missing price imputed by the model from the corresponding period. So as a better example than that, say a new laptop is introduced in February, then it's missing a January price. So its January price comes from a model of laptop prices that was produced in January. And the model that we use for this is a random forest. And that just kind of, because in testing, we looked at a variety of random forest models versus OLS models. And we just found that the random forest tended to outperform the OLS models when it came to doing the out of sample prediction, which is sort of the main thing that we are using the model for. Also some other things, like we found that a lot of outliers observations, the random forest handled better. And they did give similar final indices. It's just that the random forest one was also less volatile. Additionally, I think I mentioned earlier, there's currently 3 retailers used in production for this. We are adding more retailers. And as we add more retailers, we'll have more data. And the random forest, on top of performing better than the OLS model with only 3 retailers worth of data, we expect it to improve more as more data is brought in. And we expect it to improve at a faster pace than a regression model would. So just quick discussion. Basically, what a random forest is, it's just a set of decision trees, and all that a decision tree is doing is you take a bootstrap sample of the original data set, and you're just continuously partitioning it into subsets where each node of partition is based on whatever variable is able to best explain the outcome of interest, or whatever level of some variable is able to explain the outcome of interest, which in this case is log price. And so the random forest prediction is just the average across all the decision trees predictions. And because there's like pretty complex relationships between and nonlinearities between the observed characteristics of a computer and its price, the use of a random forest means that we don't actually need to assume a functional form for this relationship, and it can just kind of find the relationships itself. So for instance, you could repeatedly split on the same variable, and then that would capture a nonlinear relationship, which could be relevant for something like RAM, where you have a bunch of like 2, 4, 6, 8, 16, say, are the numbers you tend to see, and you don't necessarily see like a linear increase in the price as you increase the RAM by a certain amount. And it's more that as you go from 2 to 4 and 4 to 8, you could split on levels between that and find a nonlinear relation between the RAM size and price. Also, because you're continuously splitting into subsets, it just means that it can find interactions, which is relevant for things like storage space and storage type, say, because there's probably an interaction between having a solid state drive and the amount of space as opposed to a hard drive and the amount of storage space. So basically each month we have for laptops and desktops each, we have a model where we're trying to fit log price on some function of those observed characteristics. I guess don't need to say what each observed characteristic is, but for the most part, we use the same characteristics between laptops and desktops, with the exception of laptops also having controls for if it's a touch screen and the vertical and horizontal resolution of the screen. Desktops, when they are a tower, their display size is just set to 0. And the weight is kind of used as a pretty good proxy, especially for desktops, for the form factor we've found. So, so for monitors and printers, because the aforementioned lower product churn, as well as not observing the same pace of technological change, we just use a matched model for them, which is to say that if a monitor or printer was observed in the current and previous period, We just use the relative given by its current period over its previous period. And we did produce hedonic imputation indices for monitors and printers, but we found that the results weren't that different between that and the match model. So because the match model is more simple and gave a similar outcome, we just went with that for monitors and printers. So once we have the models that we can use to back price or to impute prices of entries and exits, we are able to then start aggregating into price indices. And so just very high level, what we're doing is we are taking the price relatives, and then we are taking a geo-mean of them up to a product brand relative. So a product brand would say be, for instance, brand X laptops. And then the brand, all the different brands of laptops, say, are then aggregated into a product movement, so a laptop movement. And that is yet again just a weighted geo-mean of those product brand relatives. And then in order to get the final movement used for the computer equipment, software, and supplies index, we just take a weighted arithmetic mean of the relatives of laptops, desktops, monitors, and printers. So the initial one that I mentioned, where we are aggregating the unique items within a product brand to a product brand relative, is a weighted geo-mean of all those relatives for all the relatives of the items, sorry. There is weight that is used, and basically the weight is just designed, it's just the retailers last year computer and peripheral sales split evenly amongst all the observations within that product brand of it over the total amount of sales last year of all retailers that are used for computer and peripherals. And this is simply designed to just try and make sure we don't have any sample composition effects, because we found that for a lot of retailers, there's a lot of products coming in and out each period. And so you could have some effect where some retailer has like 50 new laptops this period or 50 laptops which weren't there the last period. And we don't want to have that cause the index to move, when in reality, it's just the introduction of a bunch of different products. And yet again, I guess it's shown here that the price relatives used for all products include continuities, then for laptops and desktops include entering and exiting observations, where the price, the missing price, is imputed from the model of the corresponding period. So once we got the product brand movement in the previous, at the lower level, we are aggregating up to a product movement, and that's just the weighted geo-mean of the relatives calculated at the lower level within that product. This is a weighted geo-mean where the weights come from industry reports, where we have the sales of each brand and product. And those are user weights, and we do price update them each period. And then that is aggregated up into a product movement. So laptops, for example. Then the final aggregation, which is to the computer equipment software supplies index, is a weighted arithmetic mean of the relatives for each product. And this is price updated in a way that's kind of similar, just the way the CPI itself is calculated. So it is, it could be read as the ratio of constant quality price updated expenditures. So the current period is just the previous period. So the current period expenditures is just the sum of price updated previous period expenditures. And then this is applied nationally. So in Canada, the CPI has a bunch of subnational strata. We kind of just apply a national movement for all those, because there's been research, first of all, that we've done internally where we found that we didn't see much price difference between different outlets of the same retailer in different parts of the country in our web scrape data, but also outside sources like the Billion Prices Project have found that with the increase in online sales, that there's a lot more spatial conformity in pricing. And also just intuitively, a non-perishable good in an age of low distribution costs, it's pretty reasonable to have national pricing for these things. So in conclusion, I guess, new methodology introduced in January 2021 with corresponding data. The data itself improved the coverage, both in terms of having more observations, more brands that were covered, as well as being able to price items to capture the price change better in the period that it occurs by pricing multiple times per month. And the modeling, we now have a monthly model, which is able to adapt as the technology and market changes, which is relevant because, as we saw, there's a lot of change in the market for consumer electronics products. And we are currently in the process of adding more retailers and investigating how web scrape data and similar quality adjustment methods can be applied to more consumer electronics. So anyways, thank you. And that's all.
Thank you, Lance. We have one question that's come through from Tony Cox. I know Tony had a bit of an issue with unmuting. Perhaps we might give him another go, maybe try and get Tony to unmute Nathan if that's possible. Otherwise, I'll read the question out.
Tony's unmuted.
Okay, I'm not getting anything come through, so perhaps I'll read the question. Okay, so the question is, how does your model take account of the situation where a PC that performed the functions required by a consumer no longer available? The consumer is therefore forced to purchase a model capable PC than they require, a more capable PC than they require.
I guess, like, for instance, they just wanted to buy like they had an old computer which worked fine with just using it for the internet and everything, and that computer is no longer available, but all the new computers can do like so much more. How do we account for that, I suppose, is what he's asking. So I suppose when that computer is no longer available, we do kind of impute the price of it in the period that it has exited. But I guess I think this is kind of a recurring theme in things in trying to estimate pure price change, where we're not necessarily measuring how utility changes over time. We're measuring how the price of a constant quality good changes over time. And so we aren't really able to capture the fact that even though we aren't really able to capture the fact that all he wants is a computer to surf the internet with, say. So we're still capturing the fact that we're mainly capturing the fact that the computers are able to do more than before, and that is still considered a quality improvement.
Hello, can you hear me now?
Yeah, is that Tony?
Oh, great. Yeah, thanks for that response. What I'm concerned about is that we're trying to measure inflation, and from a consumer point of view, they want, or they were happy with a basic PC for the sake of argument, but now they're forced to purchase a more sophisticated piece of equipment. And so from their point of view, I mean, it is quite often PCs are the same price, roughly. You know, you buy a PC, it's about the same price. But if they could still buy that basic one, it would actually be cheaper now. But they can't take advantage of that improvement in quality, if you like, in terms of the cost benefit.
Yeah, so like
so
the cost.
It's really it's the end result I'm concerned about in terms of the inflation index.
Yeah, so I guess we're not really able to capture the cost of entering the market for a given level of utility. It's, if that makes sense, because we can't really observe that.
Yeah. Okay. Yeah. Thanks for your answer. Yeah.
Yeah.
We have one question that's come through from Sumit. Sorry if I've got that name pronounced wrong. Would you be able to unmute them, please, Nathan?
Thanks very much, and thank you for the talk. So there was just one point I was it would be helpful to have a little bit of clarity on. So the way I've understood it is that the true quality adjusted price of the product is unobservable. That's why you're going through the process of trying to hedonically adjust it. If that is the case, I was just wondering if you could explain how you could compare like the performance of the old versus the new models. So I think one of your takeaways was with the new one, it had a better performance. But normally I'm thinking about you kind of like residuals. And so I was just wondering if you could explain how you were comparing it, if it is the case that the true prices are unobservable.
Yeah, so I guess like the main metric used was just through cross validation, getting the out of sample R squared. And so I guess I don't want to talk too much about the old methodology because it was actually done by a different division. But I guess the out of sample R squared from like the random forest was higher than the in sample R squared of the modeling used in the old methodology. And also just out of sample R squared for the random forest models was consistently higher than that of the corresponding OLS models. If that's kind of what you're asking, just about how we were measuring, the main way we're measuring the performance of models.
Yes, that was what I was interested in. It was just one of those where, because you never observe the actual price that you're looking to record. It was a bit harder for me to kind of see, in the absence of that, how you compare one against the other. So that's helpful.
All right, cool. Thank you.
I have a question from Suzanne Ellis. Throw over to her, please, Nathan. Not sure if you're having any trouble unmuting Suzanne, otherwise I can read the question out. Just type in the Q&A if you're having any issues. Okay, so Suzanne's having a bit of trouble. So the question is, are you also researching web scraping tablets and smartphones in a similar way?
Yeah, so that's actually something that we're just in the process of getting started on. So we are, I think I mentioned, we are starting to investigate other consumer electronics. So at first, for the past few months, there's been a lot of folks on just like integrating the new retailers for the computers and peripherals products. But we are hoping to be able to fit like smartphones, TVs, tablets, smartwatches, etc., into a similar pipeline and methodology, maybe with tweaks that make sense for the product, whatever the product in question is. And so we also, I should mention, on top of like trying to apply this methodology and data source to those other products, we are in the long run trying to move it all into a common pipeline with the web scrape data that Valerie talked about earlier on, but still using the separate methodologies that fit the products in question, if that answers the question.
So we don't have any other questions currently there, but it might give half a minute to a minute for people to have a chance to type any. Otherwise, happy to move on if there aren't any. Okay. It doesn't look like there's much else at the moment, but we can actually come back to all, if we do run sort of early at the very end, there may be time for people to come back to early presentations as well. So, so perhaps if there is nothing else, we might just move on to the next talk. So thanks for that, Lance. That's very interesting.
Thank you.
So I will just load up my slides. Valerie, can you just let me know if my screens come through and my camera is visible?
Yes, I'm seeing your screen. So our last presenter is Andy Paiska from Australian Bureau of Statistics. Yeah, can we please go ahead?
Thank you, Valerie. So I guess following on from a couple of very interesting talks on sort of using new methods and new data sources, this really ties into all of that. So my name's Andy. I'm from the Australian Bureau of Statistics, as Valerie's mentioned, and we're really having quite a fascinating time working out essentially how to use a whole range of new data sources through the macroeconomic statistics, and one of them that I'll talk about today is the supermarket transactions data, and particularly how we're looking to integrate that into the national accounts. So basically what I'll be talking today about broadly is just giving a bit of a context, a bit of, I suppose, some of the underlying, I guess, drivers of the work, how we've got to where we are. So broadly speaking, the use of transactions data in NSOs, which has been a really large development particularly of the last decade, and also just some of the policy interest from various departments and governments across Australia on food consumption. Generally, sort of they're interested in how the sort of the ABS can sort of use data sets and sort of to essentially understand what's happening in our society and our economy, and that tends to sort of take, particularly for food, these sort of can be sort of described in these three sorts of questions: the what, where, and the how. So, what are people consuming in terms of what products? What about the geographic dimension? Where is it happening? And how is sort of about the behavioural drivers of growth in food consumption of people changing products? And this is something that the transactions data can really give a lot of insight into. So what I'll do then is sort of just present some results on how we've sort of try to answer these questions and some of the sort of future work. But I guess just stepping back, it is a fairly exciting time to be in macroeconomic stats. I think probably all presenters might say, without meaning to speak for them, but certainly at the ABS, there's been a great deal of work done with particularly transactions data over the last few years, looking at, within the national accounts, within other areas. So particularly in sort of the national account space, there's been a lot of emphasis on transactions data, particularly sort of, and across the sort of the world, there's been a lot of interest in transactions data, particularly from businesses. So things like bank transactions, supermarket transactions have been major focuses on how to sort of measure consumption across various economies. And scanner data has sort of been used for a range of things so far at the ABS. So I'll be focusing mainly on the sort of household consumption and the consumer behaviour side, but we've certainly been using it for public health sort of studies as well as in the CPI. And the CPI is one where the NSOs globally have been using it quite a lot, but there are so many sort of applications to this data that we're really exploring some of the ways in which it can be used. So going to the Australian context and zooming in, so food is a very important topic in Australia, probably is everywhere, but particularly Australia has some certain sort of circumstances and characteristics which mean that it's in recent years been a very significant focus for policymakers. Australia's been through quite a severe drought in recent years. There's also been some issues around supply. Recent bushfires that have been quite significant have sort of impacted on people's ability to access food at times, and a lot of these drivers have meant that a lot of government departments are really keen to understand drivers of food consumption and how that part of the national accounts, that part of household consumption has been moving. So household consumption makes up about 60% of Australia's GDP, so it's a very significant share, and of that about 10% is food. So food is a very significant slice of that picture. And currently food volumes are produced quarterly. So real demand for food is published quarterly. And at the moment, while that is a really closely watched indicator, there's a lot of opportunity to actually dig further into that. So food is a large chunk, but we don't publish it at any disaggregated any sort of disaggregated way beyond state. So, the 8 states and territories of Australia will have a food measure, but what we don't necessarily get from sort of a published indicator for total aggregate demand for food is what's actually driving it. What are the underlying product drivers? How does it vary within the states? And importantly, what consumer behaviours are driving that growth or decline in the food volume. So there's a lot of opportunity to sort of try and understand what's going on beneath that to answer some of those policy questions. And that's really where the scanner data comes in, the supermarket scanner data. It's currently sort of I suppose what I describe as sort of a perfect storm of factors that have really resulted in its use being significantly accelerated within the organisation. There's been a lot of focus on administrative data sources generally across the world, but also at the ABS. But in addition to that, there's external policy factors that I've mentioned within Australia, the cost of living pressures, the drought, and also the COVID-19 impacts on consumer behaviours within supermarkets, because Australia had sort of a very prolonged sort of lockdown sort of starting in April. And, since then it's sort of been generally on average easing off. I know that in the Northern Hemisphere, it's not necessarily played out that way. There've been sort of second and third waves and multiple significant lockdowns, but in Australia's context, there was the one sort of major lockdown, which led to some panic buying behaviour. So all of these things really pointed in one direction, and it was clearly sort of, we could see that the scanner data was going to be an obvious candidate to use to sort of provide some really important insights into sort of highlighting all of those aspects of drivers on food consumption. So it's a complicated story, but the scanner data actually gives us the tool to unpack that. So it's collected, the supermarket scanner data that the ABS gets is collected from Australia's largest supermarket chains. It has massive coverage, and it's also very granular. So it really has the sort of the double sort of, the double holy grail, so to speak. It really, and sort of just to unpack that a bit more, it really is a very big data set. It's billions of micro aggregates. It's very detailed. It literally goes down to the store level and the item level, so you can literally understand at a very low level of geography and product detail how consumer trends are going. So as I was saying before, it has very high coverage. We estimate that it's in the vicinity of 60 to 65% of all food consumed in Australia is captured in this data set, which is a point of sale data set. So basically anything that's purchased in those supermarkets is sort of essentially captured in real time. There's around 7 years in the time series, so it gives us quite a bit of recent history over those particular events as well. So you can see in that diagram sort of that it does capture the vast bulk of the food. There are obviously other sources of food consumption in Australia beyond that what's captured in that data set. But as you can see, it is a large chunk, and as a result, you can actually get a pretty good macroeconomic indicator of the whole of food consumed just looking at that scanner data. You can see that in this graph here, that broad coverage does mean that it does actually capture quite a lot. And as a result, the movements track fairly well with sort of with established indicators based on sort of industry surveys. So that's a promising sign, and it sort of indicates to us that it is quite a sort of sound data source. We've done quite a lot of testing on it, and it's sort of proven to be capable of not only replicating sort of the macro indicators that we conventionally produce, but also giving us a lot of the insights below that level. And I'll get into those insights sort of presently. So I guess going to those questions that I mentioned, the what, the where, and the how, the sort of interest from governments. The what is obviously a very important question in terms of understanding product level drivers of food growth. Obviously in 2020, this was pretty accentuated with panic buying episodes across sort of Australian supermarkets. I'd imagine this would have been a big feature of many other countries. Certainly there was a lot of interest in, what were people buying? Where were they buying it? Was it uniform across all areas? What sort, were people substituting? And what was driving that behavior? So just in terms of the product level, you can see that, for example, just in this graph, it clearly highlights that there was a significant shift towards these other cereal products, which includes pasta, sort of rice, those sorts of sort of grain products that were really a feature of the Australian panic buying episodes, which you just simply wouldn't have been able to tell without this data. So allowing that product level detail meant that we could sort of get a bit of a story about what people were purchasing, mainly sort of non-perishable foods, which obviously is important for, for understanding how to respond to that. So looking at the where question, so the geography aspect was really important, both across COVID, but in terms of you finding it, sort of giving another example, looking at how the bushfires affected consumption across the country. So in sort of late 2019, early 2020, Australia experienced some pretty significant bushfires in the eastern states, but also partly in the west as well. This really did have an impact, particularly on regional communities, in terms of how they, I guess, had access to food, had access to supply chains, just general movement of people impacted on food consumption across those areas. And the scanner data actually allowed us to look at sub-state indicators. So not just, when we publish food at the state level, that doesn't really give us that granularity, that idea of how is it impacting the regions versus the cities. The cities are very large generally in Australia compared to the regions. And I think the capital cities is around 80% of the population live in the capital cities. So generally they'll dominate the movements, whereas looking at being able to split that data by region, we could basically understand where sort of how consumption was being affected. And you can see that in a lot of the states where the bushfires were hardest hitting, things like New South Wales, Victoria, South Australia and Queensland, you can see that movement in the regions is much lower. So indicating that, for example, there were supply chain disruptions, people were leaving the areas. And that sort of, again, flows into the sort of policy response. And also the ability to get this information in quite real time, relatively speaking, compared to some conventional sources is also really important. So another sort of example, quite an interesting example, is mapping the panic buying events in Melbourne. So we saw the sort of the product level drivers of that panic buying, but there's also the geographic drivers, sort of where it happened. So this is a picture of Greater Melbourne in southeastern Australia. And you can sort of see just how the variation sort of looked across the city, and particularly in some of the wealthier areas, we did see higher incidences of panic buying, where the darker regions indicate sort of higher increases as a proportion of sort of the expenditure in the year previously. So in the city centre, there was sort of some less incidence of it, that in some of the wealthier areas along the bay and in the inner city seemed to be quite prevalent compared to the regions. So the final sort of policy question, or the sort of the analysis sort of question, is quite an interesting one, that the how. So how does consumer behavior actually drive that demand? So we've looked at where it happens, what is being purchased, but also there's the aspect of, is it quality or quantity that's driving food growth? So this is a really important question in just understanding generally how households respond to different pressures, the cost of living pressures, COVID, all sorts of situations. We want to understand, are people actually substituting products? Are people, responding to price pressures by buying cheaper things? Are they sacrificing quality? Are they buying less food? So, these things raise different concerns. And so that's something that the scanner data can actually give us quite a lot of insight into. So what you can do, and what we did as a piece of analysis, was to sort of define this concept of quality change, which is a little bit different to perhaps the quality that's been discussed in previous sessions today. Where actually we define this sort of essentially utility per unit of bulk of food. So what we're trying to understand is when the volume of food, so the real demand or real utility aggregate of food increases or decreases, is that because there is actually more being purchased in terms of a metric amount? So are there more kilograms of food across society being purchased, or is it that better quality food is being purchased, so more expensive items? And what we did was to actually define a quality metric by looking at essentially the volume per unit kilogram. And the way we can calculate that is because the scanner data has item descriptions that are fed to us from the supermarkets. They include net weights for products, and you can actually extract that data using natural language processing and aggregate a total amount of net weight food consumed in a particular period. And then looking at movements in that compared to the movements in volume, you can actually understand, is it the change in quantity, so that kilogram measure, is that what's driving the volume change, or is it something else? So you can basically infer that the residual between the volume movement, in other words, the real value of the food, and the quantity, the difference between those two movements, essentially is explained by the substitution effect. So if volume has gone up, but quantity has stayed the same, that means that people are purchasing more expensive things. Whereas if, say, if both go up at the same rate, then that's essentially an indication that the quality is, stayed the same, that it's driven by the change in bulk purchased, or indeed if volume has fallen but quantity has gone up, it means that the volume per unit kilogram, in other words, the quality of foods purchased, has gone down. So this kind of example that I've given here in the slides, you can sort of see that the top example is a quantity change driver of volume decrease. So you've got 300 grams of potatoes going to 200 grams. We've got the same product, so it's the same volume per unit kilogram, but it's a quantity driven drop. So it's fairly straightforward. The second case is a quality change driver of a volume decrease, because we've got the same quantity, 1 kilogram of ice cream, fancy ice cream, to 1 kilogram of less fancy ice cream. So a cheaper product purchased in the second period, which would indicate, if you do the maths, that the volume has dropped, but the quantity has stayed the same. So it's a quality decrease, and it's a quality driven volume change. This done in aggregate.
5 minutes remaining.
Yep, thanks. So what this allows us to do is get a time series of this quality change across the periods that we're interested in. So for example, the last few years, you can see here just what that quality change has looked like. And it's quite interesting to sort of note that quality has sort of generally as a trend decreased over time. But what happened was that in the June quarter of 2020 and the March quarter, there was quite significant contrast between what was happening. And this is something that this analysis would, uncover, that we really wouldn't have been able to see if we had used just looking at the volumes. So you can see that the volumes in March and June are not too drastically different, but they're being driven by completely different phenomena. So in March, what we're seeing is that it's actually the quantity that's driving the movement. That's the panic buying. The quantity has dropped to sort of a record low movement because people essentially just buying the cheapest thing they can get, you know, non-perishable cheap foods to fill their cupboards with. Whereas in June, essentially the opposite has happened. You've actually got this significant increase in quality and a drop in quantity as people's pantries are already full. And people essentially, because they're in lockdown, restaurants and other sort of takeaway services have largely been closed. So people have slightly more disposable income. They're sort of replacing restaurant meals with home cooked meals. So they're actually, the hypothesis goes that, you know, they're purchasing better quality products. So without this analysis, you might just think, oh, it's the same thing happening in March and June, whereas it's actually completely opposite behaviors. And we've been able to sort of capture that through this analysis. So one thing that we did look at is there an association between price and quality change? And we did find that across food in total and across a lot of categories that you can see listed there, there was an inverse relation. And we've sort of just plotted there the price and quality change relationship. And you can really see that there is quite a clear association between them. So households are responding to price signals through substitution based on this quality change metric. And that's something that, that we're sort of looking to track as well. So just in conclusion, scanner data has really proven itself as having a lot of capacity to add sort of interpretability to estimates and sort of being able to give extra depth to what we publish. So we're really looking to advance that work. It's already had a lot of use in explaining a lot of key events to users, like key government departments around bushfires, COVID-19, and other behaviours. So it's already had a lot of really good response from governments, and they are very keen to see more of it. And as I said at the start, this is really just the beginning of the journey of sort of using this in national accounts to sort of improve our estimates. And we're interested to hear what people here might think around, if this has sort of triggered any ideas in your mind about how to use this sort of data. So that was sort of a broad flavour, and I really only had time today to give a sort of flavour of what's been done. But I thought I'd just sort of give you a broad overview just to get you thinking. So I guess if there aren't any questions, or if there's something that you might want to engage with, and sort of just put a few points there. Do attendees know of any other NSOs using scanner data or similar transactions data? We're very keen to sort of make connections. If your organisation had access to this sort of data, this point of sale granular data, what might you do with it? And generally, do you just have questions or comments around sort of concepts and methods that I've discussed today? So I'll leave it there. So thanks for your attention, and I'm happy to take any questions or comments.
Thank you, Andy. We will take a question from Barakeze. Please unmute your mic.
Hello, can you hear me?
Okay.
Yeah. Hi, Andy, how are things? Thanks a million for the presentation. My name is Barra Casey from the Statistical Office in Ireland. My question was just around, from an organisational structure point of view, how do you organise yourselves? I suppose I'm just kind of interested in terms of, we're kind of just starting out in this path, so we're kind of thinking about, managing relationships with the retailers. Do we set up a separate data acquisition team, or in terms of should this work kind of be done separately from the CPI team? So I'd be kind of interested, in kind of how you've structured yourselves in Australia. And just to say as well, you know, I'm kind of very interested in you know, what you're saying in terms of how you're using the scanner data there as well, you know, because I suppose traditionally NSIs have used scanner data for price statistics, you know, but you're kind of coming at it from a very different angle there. So I'm interested in that as well, you know, because it's a much wider kind of use case for scanner data compared to kind of what I've seen. I work in the price statistics area, so probably traditionally I've just seen kind of the use case from a price statistics point of view. Thank you.
Thanks, Barrett. Yeah, look, I'm glad you make that last comment, because we were, you know, struggling really to find a lot of literature in this space and of using scanner data beyond, I guess, what has been, you know, I guess a more widely sort of acknowledged use case, widely tested use case on CPI. So yeah, definitely I'm glad that yeah, you've seen you've got some interest out of today. Now in terms of the structuring our organization for acquisition, look, we've been receiving this data for about there's about 10 years, so that there's you know, various suppliers of the data, and they didn't come all at the same time. They're organized through sort of individual memoranda of understanding with various providers. Now in terms of the actual acquisition, I believe that's just done through our sort of acquisition center. But basically it's a matter of getting I suppose interest from different providers, and you know, getting providers to understand the value of the data that they can provide, which, you know, has its challenges, but it's certainly proven to be really worthwhile. So I'm not sure. Perhaps you can expand on whether there's particular things that you'd like to know. I'm not an expert on the data acquisition aspect, I have to say, but if there's particular sort of particular focus to that you'd like me to try and elaborate on, let me know. I may not have understood the question, but
yeah, no, I think the point, my question really was, you know, kind of, do you have a separate team, entirely separate, you know, kind of from your CPI team? And from kind of what you said there, I think you do. You can have you mentioned you have an acquisition center, you know, yeah, so yeah. It sounds like a kind of a central unit where you collect data, right?
Yes, so that's broadly how we sort of organised ourselves. So CPI are a major user, obviously, of the data, but my understanding is that all data acquired in the ABS go through a particular through the acquisition center. So yeah, that's
great. Thanks, Andy.
That's how I'd answer. Yeah.
We will take a second question from Rubina. Please unmute your mic. Rubina? Okay, I'm going to read the question from Rubina. The quality concept here is different from what we call shrinkflation, which itself is an implicit quality measurement method. If so, how do you reconcile these two concepts in your final measurements?
Yeah, thanks, Rubina. That's a really good question. So this is where the definitions of quality can get a little bit hairy to sort of unpack, because they're two slightly different things, I guess, going on. So I guess shrinkflation is inherently captured in, I mean, in supermarkets, we do get a measure of the weight metric. So I guess all shrinkflation, so to speak, is sort of visible. It's a little bit trickier in sort of the I guess the parts of the CPI where you don't necessarily have a very good indicator of quantity. it can be a little bit harder to assess how that's sort of flowing through to estimates. But because we're sort of assuming that the weight metric in the product is pretty good quality, we can sort of work out if shrinkflation is going on, and that will naturally translate into the aggregates. So, if a particular product has had its packaging, decrease over time in net weight, but say its price has stayed the same, then that would naturally flow through to that ought to flow through to a lot lower volume, because that ought to be captured in the CPI, which do look at quality adjustment based on net weights of packaging. So in theory, and I mean, I think in practice generally, because that's done fairly meticulously using the same data, that ought to be captured within the quality change metric. So the quality change will be looking at a sort of a pure volume per unit kilogram, and if the size of a particular package has decreased over time, then that ought to still be showing, essentially should be showing that contribution of that product should still be sort of the same quality, because it's just the packaging that's increased or decreased, whereas the volume per unit kilogram has stayed the same for that item, but its price per unit kilogram may have actually gone up or down. So I'm not sure if that answers your question, but that's sort of how I'd address it. It's two slightly different definitions of quality. One, the quality as CPI would see it is actually the size of the packaging. So, if something has, like a can of baked beans has gone from 300 grams to 280 grams, that's considered a quality decrease. Whereas from our perspective here, that would be considered a quantity decrease. So from, the net weight has gone down. So, but combining the volume and combining the CPI and the volume measures, those ought to flow through in a consistent way.
Thank you, Randy.
Yeah.
The conversation can be continued by going to the conference chat room or by messaging the presenters privately on the platform. Please join the coffee break at 2:30 p.m., which can be accessed via the lecture room section of the platform. There are 3 rooms. Rooms 1, Economic and Statistics in Practice. Room 2, Productivity, Digital and Welfare. Room 3, Methods Nowcasting. Thank you.